With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem simply state what is meant by soft and hard X-rays. How can the intensity and penetrating power of X-rays be controlled? And in the next part, we have to derive an expression for total energy of an electron in nth orbit of hydrogen atom. So let us first try to solve the first part. Now, what is meant by soft and hard X-rays? Let us draw a diagram for clear understanding. Now, let us try to understand the concept of soft and hard X-rays with the help of this diagram. Now, this is a symbolic diagram only. The actual apparatus may differ slightly. Now, X-rays are usually produced in a Coolidge tube. So, this is a symbolic diagram of Coolidge tube. This is simply Coolidge tube. Now, this tube is highly evacuated so that there is no air molecules inside in this tube, and this is your filament F. Now, when the current flows in this filament simply gets heated up, and what happens is that as this filament simply heated up, thermions, that is the thermal electrons, are simply ejected out from this filament. These thermal electrons are simply accelerated by the potential difference between the filament and this metallic target. This is a metal target of very high melting point like tungsten. So this is a metal target. So as these electrons strike this metallic target, so what happens is that they get retarded, and then due to that the X-rays are simply produced. Now what are soft X-rays and hard X-rays? Now soft X-rays are simply X-rays whose energy is low, and so their penetrating power is also low. Let us say that these are soft X-rays. So what happens is that in soft X-rays, two properties are there. In soft X-rays, first thing that is there is their penetrating power is low. Penetrating power is low. That is why they are known as soft X-ray. And why their penetrating power is low? Because they have less energy than hard X-rays. Why they have less energy? Because their frequency is slightly less than the hard X-rays. They have low energy. Now let us assume that this is hard X-rays. These are hard X-rays. So hard X-rays have higher energy than soft X-rays and higher penetrating power, right? So penetrating power is simply high, and they also have high energy, right? So this is the concept of soft and hard X-rays. Now, how can the intensity and the penetrating power of X-ray be controlled? Now, how can you produce intensity means how can you produce more X-rays? By simply you can understand that if more electrons are falling on this metallic target, then more X-rays will be simply emitted, which simply means that the more intensity. So we can increase the intensity. To increase the intensity, we have to increase the current that is flowing in the filament so that more thermions or thermal electrons are emitted from the filament so that the intensity is increased. To increase the intensity, what we have to do is we have to increase the current. That is, the current flowing in the filament should increase. And how do you increase the penetrating power? See, it is very simple. More will be the energy carried by the X-ray, more will be its penetrating power. So how can you increase the energy? You can simply increase the energy if you can somehow increase the kinetic energy of the electrons, and you can do that by simply applying more potential difference between the filament and this metallic target. So their penetrating power can be increased by increasing the voltage difference or the potential difference that is used to produce X-rays. If you use more voltage, more energetic X-rays or more hard rays will be simply produced and their penetrating power will be more. If you use less voltage, then there will be less electrons will have less kinetic energy and the X-rays produced will be soft, or they will have less energy and less penetrating power. Now let us move to the next part. We have to derive an expression for total energy of electron in nth orbit of hydrogen atom. Let us draw a diagram for clear understanding. So you can see here in this diagram, this is the nucleus of hydrogen atoms and this is the electron which is revolving around the nucleus in circular orbit. Let us say that we know that this electron simply moves with the constant speed v and the radius of this circular orbit is r. Now how can you find out the total energy of this electron? Now the electron is moving, so it will have kinetic energy, and there will be some electrostatic attraction between the electrons and the nucleus, due to which it have electrostatic potential energy. So if you want to find out the total energy of electrons in nth orbit, then what you have to do, you have to find its kinetic energy and you have to find its potential energy, which will be simply due to the Coulombian attraction. So if you want to find out the kinetic energy, you should know the value of speed. And if you want to find out the potential energy between two charges, what you should know is that the distance between the charges. Let us first try to calculate these two parameters. So how can you calculate the speed? Now, first thing that we know is that there is electrostatic attraction between the nucleus and electron. So the first thing that we can say is that the electrostatic force acting between the nucleus and electron is simply nothing but 1 upon 4 pi epsilon naught Z into E. This is the total charge inside the nucleus. Here Z is simply 1, but we will put the value later. So ZE into charge on an electron is simply E. So this is simply E whole divided by, let us say that the radius of this orbit is R. So it will be R square. Now there is only the electrostatic force which is acting. So this force has to provide the necessary centripetal force, that is the electrostatic force must be equals to the centripetal force. Now let us put the value. So this will be simply equals to 1 upon 4 pi epsilon naught Z E square whole divided by R square. And what is the formula for centripetal force? It is simply m. M is the mass of the electrons here. V square, which is the speed of the electron in this orbit, divided by R. Now from here you can see that this will get cancelled and you can calculate the value of R from here, which will be simply equals to ZE square. Now this will be simply equals to ZE square whole divided by, now this mv square will simply comes in the denominator, so this will be mv square into 4 pi epsilon naught. Let this be equation number 1. Now here you can see that we do not know the speed. If we know the speed, then the radius is simply found out and we can calculate the potential energy. Now let us apply the Bohr's postulate to find the speed. So what is Bohr's postulate? Bohr says that the angular momentum of electron in any orbit is simply quantized and it is an integral multiple of h upon 2 pi. So if you apply Bohr's postulate, it says that the angular momentum, which is simply mvr, is equals to nh divided by 2 pi. So from here you can find out the value of v. So you can see here v will be simply equals to nh divided by 2 pi m into r. Now you can see here from this equation we can put the value of r here in this equation, then we will get the value of v. So let us try to put the value of r here. So you can see that the r is this value, so let us put, so this will be nh whole divided by 2 pi m into, in place of r we can put this value, so this will be z e square and this part will simply go in the numerator, so this will be m v square into 4 pi epsilon naught. Now from here you can calculate the value of v very easily. So you can see that this will simply cancel out. this pi and pi will cancel out, 2 and 2 will cancel out, and from here you can calculate the value of V. So V is simply equals to ZE square, this M, and M will also cancel out. So V is simply equals to ZE square whole divided by, now you can see that what is left here is NH, and this is 2 epsilon naught. So NH 2 epsilon naught. Let this be equation number 2. Now once you know the value of V, you can put the value of V in R and you can find out the radius. So if you put the value of V here, so you are going to get the radius as, this will be equal to, now radius, you put the value of V square here, so radius will be simply equals to epsilon naught H square N square whole divided by pi M pi M ZE square. Now this will be your radius. Let this be equation number 3. Now you know the speed. Now you know the radius. Now what you need to find is kinetic and potential energy. So how do you find out the kinetic energies? So you can see that kinetic energy of the electron is nothing but it is equals to half M V square, and if you put the value of V square here, so you are going to get the kinetic energy of electron will be positive and the value will be simply M mass of electron into Z square e to the power 4 whole divided by 8 epsilon naught square H square N square. So this will be the kinetic energy. Let this be equation number 4. Let us now try to find out the potential energy. So how do you find out the potential energy? It is simply equals to 1 upon 4 pi epsilon naught into Q1 Q2 divided by R. Now here the Q1 is simply ZE and the Q2 is nothing but it is minus E. So whole divided by R. Now you need to put the value of R from here. So you get the value of potential energy as, potential energy will be simply equals to M Z square e to the power 4 whole divided by 4 epsilon naught square H square N square, and this will be simply negative because you can see that the charge of the electron is negative, so this will be negative. Let this be equation number 5. Now as I told you earlier, how do you find out the potential energy? So you can simply, how do you find out the total energy? Total energy is simply equals to the sum of kinetic plus potential energy, which is simply U here. Now you can put the values of kinetic and potential energy and then you can get the total energy of the electrons, which will be simply equals to M, which will be simply negative, and it will be equals to M Z square e to the power 4 whole divided by 8 epsilon naught square H square N square. So you can see here this is the energy of electron in nth orbit, because here we have n, so this is the energy of electrons in nth orbit. So from this formula we can see that all the parameters m z is simply 1 here. We can also put the value of z for hydrogen atom, for H atom we can put the value of z equals to 1, and we can get the final expression, which is simply En is equals to minus M e to the power 4 whole divided by 8 epsilon naught square H square N square. Now from here you can see that the total energy of electron in a particular orbit is simply inversely proportional to the square of the orbit. I hope you understood the entire explanation. Thank you.
For class 6 to 12, ITG and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.